Hello everyone, and welcome to our next lecture for part of section 3. Today we're going to talk about condensation and hydrolysis reactions and also how phosphates fit into this section. So before we get started, I did want to say that for this lecture, I went ahead and made these slides available so you won't have to do quite as much drawing, and it can save you some time, especially when we get to the biochem spot. So even if it doesn't make it into this video, for the next video it's got a lot of biochem drawing stuff. So basically I just provided the notes, but they're not complete notes, so you're still going to have to add your own stuff. Obviously, you want to add interesting things or things that you find will help you remember stuff later, but also you're going to have to add like products to the reactions and things. And you can find that on Blackboard in the supplemental reading folder, so go check that out and either print them out or download them if you want those. So let's go ahead and get started. So as we said, we're going to be talking about organic reactions for pretty much the whole semester. We're going to talk about two different ways that we can look at the reactions from this section, and then we're going to talk about some reactions with a biofocus. Specifically, we're going to talk about condensation reactions, hydrolysis reactions, and then see how C double bond O and P double bond O are similar. So first I want to talk about how phosphates actually fit into this chemistry. So as we said, we're talking mostly about carboxylic acid derivatives. So as you can see here on the left, we've got a carboxylic acid, and then on the right, it's forming an ester. Then if you look below, we have an analogous reaction where we have a P double bond O with an OH, which looks kind of like a carboxylic acid, except for instead of having a C, we've got a P. And then it's also reacting with an alcohol. And if you look on the right, it's a similar situation. We've got a P double bond O with the thing that would look like an ester. It's actually called a phosphate ester. So let's break it down to the substitution part. So it should look like this if we break apart the pieces. So for the carboxylic acid, we're actually taking off the OH, that's going to be our leaving group, and then we're going to replace it with this O carbon group over here, and that's the part that's new, right? So because this is a substitution, we're just replacing something. And then what the byproduct that we're going to form is going to come from that leaving group is going to be water. So instead of being an OH minus, which is not a good leaving group, we're going to end up with an H plus on there, and it's going to make water. So that's over here on the right. So then if we do the same thing with the phosphate reaction, it would look like this. So now we have the phosphate OH is going to be replaced by the O carbon, and we're also going to form water whenever that acts as a leaving group. The mechanism would actually be very similar. So as we see in the top, the main part of the mechanism is this nucleophile is going to attack the carbonyl, and then the electrons go up, and then we make a better leaving group, and then it's going to come down. Well, the same thing can happen to the phosphate, where the nucleophile can attack at the phosphorus, and then, it can make a better leaving group and do what it needs to do, and then that's going to cause it to form this thing on the right. Now, you'll also notice there is a difference here, whereas the reaction at the top is catalyzed, that cat means catalyzed, by an H+, that means acid. And in the bottom, it says enzyme. So generally, the reactions we're talking about are going to happen with enzymes. So we're going to sort of focus on that sort of chemistry. So there's going to be a special enzyme that's going to make this reaction go faster, but the overall reaction is still the same process. So with that, we're going to move on to the types of reactions, but just FYI, when you go back, these are actually all condensation reactions, and then we'll show you some hydrolysis reactions with phosphates later. But I just wanted to point that out in case you were looking at them later. So basically in this section, we're going to talk about the reactions in a slightly different way than we have been in class so far. So as a chemist, I tend to think about things about reactivity based on the functional group. So when I see a certain functional group, then I'll know what to do with it, like what could it do in a solution. But biologists might group it a little bit differently. So they tend to think of things in more categorized sections because those types of reactions have similar enzymes and things. So I'm going to talk about these reactions also in the format of condensation and hydrolysis reactions. So first we're going to talk about condensation reactions. A condensation reaction is where you have two organic molecules that combine to make one organic molecule, and then you have water as a byproduct. So if you've ever heard of condensation like on your glass on like a hot day, if you have a cold drink, you get condensation where water comes out of the air. In this case, the water's coming out of the molecules. So it's a totally different process. Obviously, one is not a chemical reaction at all if you have condensation on your drink. But in this case, it actually is a chemical reaction where it forms a byproduct of water. We're actually going to find that it doesn't form exactly water, and it doesn't form exactly like this, where the hydrogen on the OH does not actually go onto the OH from the carboxylic acid. It's a different hydrogen, but it gets the idea across, and it helps you sort of remember it, so that's just how it's grouped. All right, so if we look at this reaction, basically what's going to happen is the nucleophile is going to tack this at the carbonyl, right? And then you're going to have this OH as a leaving group, but before it leaves, it's going to get a hydrogen on it. So this is not the actual mechanism. I don't want to go through that right now. We're going to have a whole day where we're going to talk about how to make esters and amides, and that kind of goes together. But what I want to focus on today is just how to categorize the question and how to recognize, like, predict the products, right? So if we look at this, basically all we're going to do is take off the OH on the carboxylic acid and stick this O on and just make sure you have those carbons on there. So if we look at example 2, we want to do the same process. So what are we going to do? We're going to take the O, right, on this alcohol here, which is actually a phenol, but that's okay. And we're going to have it attach at this carbon with the double bond O. And then we're basically just going to chop that OH off because that's what's going to leave as water. So the product should look like this. So I'll draw the carbonyl part first. And then I'm going to stick the O on there. And then I'm going to put the thing that was on the alcohol on the right. So then that will be my product. So go ahead and do the same thing with the next one. Now, in this case, we are going to have to do something a little bit different. What's different about example 3? Right? It's got a nitrogen on the nucleophile instead of an O on the nucleophile. That's what I said about we're not grouping them by functional group anymore. We're grouping them by condensation, but it's going to have the exact same process. So what's going to attach to the double bond O is going to be the thing with the lone pair, and then the OH is still going to be the leaving group. So draw what you think that product would be. Pause the video and do that. Is this what you got? All right, great. So notice also there's a difference here. For the first one, the alcohol lost the H and it was just an O. But for this one, we only lose one H on the nitrogen, so it's still going to have one left over. So generally you want to draw that down. Don't draw it in between the bond like this, because that's actually not correct line bond form and it just looks terrible. So don't draw it like that. Just draw it with it either down or up, just so it's out of the way of the carbon-nitrogen bond. And just to make sure we're all on the same page, if you didn't get this product, basically what I did is I took the lone pair from this nucleophile here, and then I attached that to the double bond O, and then I took off the OH. So that's how I got that. And then obviously I still have to remove one of those hydrogens. So one of those hydrogens had to go. All right, so the same process. Hopefully that makes a little bit of sense. Now, if we want to do a similar thing with the phosphates, we're going to do basically the same idea. So we're going to take the O here and the lone pair here, and it's going to attach at the P double bond O, and the same kinds of thing would happen. The electrons would go up like this, and so if we drew that intermediate, it would look like this. You probably noticed there's a lot of minus charges on this. This is not the exact mechanism. We're just going to think through it using a partial mechanism. What's actually happening is the enzyme is actually covering up some of these negative charges. Or it's either an enzyme or a cofactor. It depends on which system you're in. So generally, like things that would normally work with an H plus are going to work with the enzyme. So we're just going to do like the shortcut version and just have these minus charges on there, and it'll be fine for our purposes, right? It'll get the idea across. So basically, that's what it's going to look like for now for us. So then once the minus charge is up here, we would make the OH from the alcohol not a good leaving group. So we do that first. So then if we draw that, that's going to look like this. And then we'd also want to make the OH on the P a better leaving group. So we could say it added a proton, or it's just activated by the enzyme, but we'll say proton for now. And then the leaving group would leave, and these electrons would come down as the leaving group leaves. So it would basically look like that. So that would be the same sort of process. It's just it would happen with the enzyme. So the product then would look like what? Right, it's just going to be the whole thing on the left without the OH, and then we're going to stick the green thing on there without the H so that you get the O where the PO is over here. So then that would be the product plus water, which you don't have to draw. It's just a byproduct, but it's the same process. So hopefully that now looks a little bit more familiar and you can see how those are more similar. So those reactions are all condensation. Again, they're just adding something with an O or an N, something with a lone pair, a good nucleophile, to something that's either a C double bond O or a P double bond O. And then the leaving group is leaving as water. And that's like sort of the key thing that makes it condensation, is that it's forming water as a byproduct. Okay, but let's look at another reaction. So with that, let's take a break. Basically, condensation reactions we've covered, but we still need to cover hydrolysis reactions, and then I'll cover some biochemistry stuff. So make sure that you stay tuned for that. Just come back to the next video, the second video for today's lecture. Thanks, bye.